morning, good afternoon, and good evening, wherever you are. Thank you for joining. At CIQ, we're focused on powering the next generation of software infrastructure, leveraging the capabilities of cloud, hyperscale, and HPC. From research to the enterprise, our customers rely on us for the ultimate Rocky Linux, Werewolf, and Apptainer support escalation. We provide deep development capabilities and solutions, all delivered in the collaborative spirit of open source. Good afternoon, gentlemen.
Hello, hello.
Oh, can't hear you, Jonathan.
Oh.
Uh-oh. Technical difficulty 1.
Oh.
How are you, Brian?
Doing well, doing well. How are you, Zane?
Doing good. Good to see you. It's been a while. I feel like I haven't been around
Yes,
in a while.
yes.
On the road a lot.
Yeah, it has been a while. Yeah.
How about
Good
this?
to be back on.
There you are.
Yeah.
There we go. Nice.
I'm in a different place with different audio equipment, and so everything freaked out. It didn't know what to attach to. I'm happy it didn't try and use my phone as my camera. It often likes to do that.
That's frustrating. Well, welcome, gentlemen. It's good to see you. It's been I haven't been on in a while. I've been traveling, doing a lot of other things, but it's good to see you guys. I know you guys have been on more recently than I have, so welcome back to everybody. If you don't mind, we could introduce yourselves. Again, I know you've done this many times, but just for those who are stopping by to talk about Fuzzball, tell us who you are, what you do. Jonathan.
Yeah, my name is Jonathan Anderson. I'm an HPC engineer here at CIQ, working primarily on Fuzzball these days, although I also help with maintenance of Werewolf and other things too, but that's where my primary focus is.
Thank you, Jonathan. Brian.
Hey everyone, Brian Fan here, also an HPC engineer here at CIQ. I also work on the Fuzzball product, and my background's in HPC administration and architecture, and it's good to be back on this webinar to talk about Fuzzball.
That's great. Thank you. So I think one of the things we've talked about Fuzzball a lot over the last couple of years, but I think now we are to a place where we're talking about Fuzzball on-prem, right? Is what you guys are here to talk about today. And I would love to dive into this and kind of give an overview of what Fuzzball is. And then we can dive into the things that have changed a little bit or that you guys have really been focused on, including kind of what IQ was, what an operator has turned, or what that's turned into from an operator perspective. But if you don't mind, just kind of high level. Brian, what is Fuzzball?
So Fuzzball is a workflow orchestration platform, which is, I guess, part of what CIQ calls HPC 2.0. With this workflow orchestration platform, it's got its own workflow definition language, and where you could build workflows consisting of various jobs. And you could also do the same in a web UI as well. And this whole platform basically enables performance computing, and at the end of the day, also reproducible scientific computing. Jonathan, is there anything you'd like to add to that?
Maybe the only other thing that I'd add to that is everything is developed kind of API first. And so the parts of Fuzzball talk to each other over a defined API, and then an API is also exposed to the end users. So some of our customers are using that to develop, they use a Python SDK that we generate from that API, and allows the whole system to be orchestrated and automated even from outside of Fuzzball.
Very nice. Thank you. So one of the things I remember when we started this was hearing a lot about iCube. So if we could kind of go into the iCube history, what it is, why it existed, and kind of what has it become today, or what are we doing differently now?
Sure. So to my understanding, iCube was a provisioning tool developed by CIQ, which encapsulates, I guess, a CIQ flavor of Kubernetes and also the Fuzzball Orchestrate platform. And the goal of iCube was to be able to provision the Fuzzball Orchestrate platform with the Kubernetes engine that it runs on onto an on-prem system. And through this iCube tool, it was also designed to be able to also deploy in air-gapped type of systems as well. But yeah.
Jonathan, do you have anything? Like, nod your head. Just making sure you have something to add.
Yeah, I mean, that seems right to me. That a lot of it just comes down to where what we consider the scope of our domain. What are we responsible for? And the biggest thing to know as a point of history, is that iCube considered the Kubernetes environment part of our domain, and that's part of a shift in our on-prem deployment strategy that I expect we'll talk about in a moment.
Absolutely. So I think that actually leads right into the shift, and now we're talking about creating an operator. So maybe not leveraging iCube as much or at all, and moving more towards a real Kubernetes operator. So what have we done there, and what does that mean?
So using the operator model, which is, I guess, a common type of pattern used when administrating Kubernetes systems, we've basically designed the operator to be able to deploy the Fuzzball Orchestrate platform onto a existing Kubernetes cluster. The specific platform that we've tested on is Rancher Kubernetes Engine 2, which is what we will be kind of demoing today in our demo. So yeah. Jonathan, is there anything else you'd like to add?
I'll just add on to that. Like that's what we, and I say we very specifically, like Brian and I have been using internally, because RKE has been really great to kind of spin up really quickly. It's been easy to get up and running with. And then when we were doing some of this work, it was what one of our clients was specifically interested in using. So it was our first target. But we have had other people in the company deploy on other Kubernetes platforms without any reported issues. So we're working on getting that kind of proven out, and just developing a list of what we consider a tested platform. But so far we haven't had any reason to think that it wouldn't work on any reasonably standard compliant Kubernetes.
Great. So I think one of the things I want to make sure we delineate here is we keep talking about Kubernetes and orchestration and then high performance computing. Can we differentiate what Kubernetes is doing for us in this environment versus what goes on inside of an HPC cluster? So not necessarily running Kubernetes on an HPC cluster to do work, but using Kubernetes to do what?
So basically, we're using Kubernetes to run the various microservices to manage the workflows and data, software, images that are being orchestrated for your particular workflow. But at the end of the day, your workflow is actually running on bare metal, which the orchestrate platform, runs which orchestrate basically will run the job on bare metal through orchestrating the workflow using these microservices.
Yeah, I don't want to, maybe you were planning on this at another time, but this might be a good opportunity to put the diagram that you've put together for this.
Yes,
Brian, that might make it. And then we can gesture to that and say what parts of it are in Kubernetes and what part are not.
For sure. Let's get this shared out. Perfect. Just gotta give it a second.
It's not like changing the flow of the conversation, guys. Sorry.
No.
Cool. So when jobs are submitted to, so Fuzzball Orchestrate is running on Rancher Kubernetes Engine, which, as you can see here on this controller node, jobs are submitted into Fuzzball Orchestrate, and on your compute nodes, we have something called Fuzzball Substrate, which is, you can kind of think of this as a task runner that runs various jobs that are submitted to Orchestrate. So Orchestrate will stage the various data and software containers onto the substrate node, and eventually end up running your job on this particular compute node.
Yeah, so if you're coming from a traditional HPC environment, if you've run Slurm, Fuzzball Orchestrate is kind of like the Slurm Control D. The Slurm Control D and Slurm DVD rolled together, things like that. And then Substrate is like the Slurm D that runs on your compute node. And if you're coming from a PBS environment, then Fuzzball Orchestrate is like the PBS server, and Fuzzball Substrate is like the PBS mom, that kind of thing. But it adds extra functionality. You have Substrate is also a container runtime, because every job in Fuzzball is containerized. So it does all of that transparently as part of the agent.
I don't want to go too far into it, but when you say containers and a container runtime, what container formats will it run? The runtime on Fuzzball Substrate can, technically speaking, it's always running like a SIF, a Singularity or Aptainer style image. It can transparently convert
OCI container images as part of the workflow. So you can bring containers to it in either CIF or OCI format, and it will do the right thing.
So any kind of OCI compliant container.
Yeah.
Okay. Thank you. I think now we kind of started down the whole diving into an overview of Orchestrate, high level. Again, I took you a little bit off track. Sorry. So if we want to go into that now and talk about workflow orchestration, resource management, scheduling, I mean, you kind of touched on it, Jonathan, but is there more that we should go into?
I don't know. Like maybe just reiterate. Like a fuzzball executes workflows. Those workflows are a collection of jobs that can be related to each other through dependencies, and then the workflows are processed in Orchestrate and dispatch jobs, which are either the compute jobs that you want to run or kind of ancillary jobs like pulling an image or doing ingress egress, that kind of thing. Those all execute outside of Kubernetes on your compute resources that are running Substrate.
Thank you. And I've heard talks of fuzz files. What are fuzz files?
Go for it, Brian.
So fuzz files are basically the fuzz are your workflow definitions, which are submitted to Fuzzball Orchestrate. So within this workflow definition, you can have a collection of jobs, like Jonathan mentioned, which can be related. Using either the CLI or the web UI, you can take this fuzz file, submit it to Orchestrate, and have your workflow run on your various compute nodes running Fuzzball Substrate.
These are typically YAML formatted files. I think they can be JSON as well, but we pretty much always do them with YAML.
Very nice. Thank you. I think now you guys have something to show us, right? You're going to see this thing in action?
Yes. So,
Awesome.
So for today's demo, what we will be demoing is the installation of the Fuzzball operator from CIQ Mountain. And then once we have the operator, we are going to use it to deploy Fuzzball Orchestrate into the RKE cluster that we have running on this controller node. And then finally, we will go and install Substrate on our compute node just to get a compute node up and running. And then from there, we will switch over to a deployment I have up and running, as this takes some time to get up and running. So we'll switch over to that, where I'll demo what a completed deployment will look like. And from there, we'll submit a couple jobs into Fuzzball Orchestrate, and I can show you how jobs running within Fuzzball kind of looks like from both a CLI perspective and also a web UI perspective.
And Brian, I see that we got a question from LinkedIn at some point just asking for clarification on what an operator is. So either now or as you're doing the demo, can you make sure that we give that? Because I think it's easy for us to be like, just say it and we know what that means, but we could give it a little bit more detail.
Yeah, would you be able to take that one, Jonathan?
Sure, I'll do that.
I'm
No
not
problem.
the most well-versed in Kubernetes, so take that one, please.
The operator pattern is just the idea that you deploy a container into the Kubernetes cluster that itself manages aspects of the cluster. So for a relatively complex deployment like Fuzzball is, this can be a good strategy for having a lot of flexibility in how your Fuzzball cluster is deployed and managed, and it also makes upgrades a lot easier. So it's like we took a chunk of what iCube was, and instead of running it outside of the cluster and having it be kind of proprietary and bespoke, we deploy it as a container inside the cluster. And so it has full access to the control plane of the Kubernetes cluster that we're deploying Fuzzball Orchestrate into. And then coupled with that is a custom type. So if you haven't used Kubernetes before, it's kind of like a big collection of objects that define, typically in YAML format, how you want things to be deployed. So we have a Fuzzball type, custom type that we've defined, that says how you want your cluster, your Fuzzball cluster to be deployed. And the operator controller sees that definition, and makes your cluster be configured the way that you want it to be. And so if you want to make configuration changes, you can just edit that object in your cluster, and the operator controller applies those changes throughout the cluster as necessary. If you upgrade, you just upgrade the operator, or you upgrade the operator, which upgrades the controller, which puts the new version out into the cluster. And it's all been quite seamless and a good experience. And then it integrates into CIQ's Mountain platform as well, because all of the containers that are needed to do this deployment are just pulled right out of Mountain, and the installation of the operator into your cluster in the first place is done directly from Mountain. So it's kind of the more, or at least a more native or community typical way to do this kind of a Kubernetes deployment. And yeah, we think it'll be much more streamlined, in addition to supporting deploying into customers' existing Kubernetes environment.
Cool. Thank you, Jonathan. All right. So with that being said, I guess we can jump into the demo. So give me a second. I'm just going to switch my screen share real quick. Okay, so and cool. Is the font size okay here?
Go another couple, just to make it a little bit bigger. There we go.
There we go. Maybe.
Thank you.
Is that better?
Yes.
Now that I think now that it's wider, make it bigger again.
It did reset.
Oh, okay. How's that?
That seems good.
That works.
Okay, cool. All right, so I'm on this controller node that was in the diagram that we previously shown. I guess to start off, I am going to start off by installing the Fuzzball operator. So to do that, I am going to first use Helm to log into Mountain. So I have a Mountain access key, which I have set in my environment, and this will basically use Helm to log into CIQ's Mountain so that I could pull the Fuzzball operator into the Kubernetes cluster. So start off by doing that. Once logged in, now I'm going to set a couple of environment variables to, I guess, pass into my Helm command to pull the actual Fuzzball operator. So as you can see here, things like the version that I'm pulling, the URI to the Helm chart, and the URL to the image that I want to pull are being set. So once those are set, I'm going to just paste this command right here. I'm going to, I guess, call Helm and pull the Fuzzball operator from Mountain. And in doing so, I'm basically passing in things that I set before, like the version, pointing it to Mountain right here, and then also providing it some credentials to actually access these artifacts, which are provided through Mountain. I should also mention everything that I'm showing today is available in our documentation at beta.fuzzball.io/docs. So if you ever want to reference anything that I'm running today, you can definitely take a look there. So from now that I got this command pasted, I'm just going to run that, and it will start installing the Fuzzball operator. So from there, we can see that I have kube control. So I have kube control on this node, which is running an RKE2 cluster. And from using kube control, I can take a look at the Fuzzball operator being installed. Jonathan, could you provide a little bit more color on what this PVC command does?
Oh, sure. So there's a number of just smoke test things that are in our docs for seeing that the operator is installed properly. The PVC is it stands for persistent volume claim. This is a Kubernetes thing. This is that the operator needs a place to store its information, and seeing that the Fuzzball operator controller manager persistent volume claim has been created and is bound to a location that's bound to this volume that was generated on its behalf. It's just one step along the way showing that the operator installation has been successful. It has a location to store its state.
Gotcha. Thank you, Jonathan. So the next command I'm going to run is kubectl get CRD. I believe CRD stands for Custom Resource Definition. And basically, the Fuzzball Orchestrate platform is this custom resource definition that we're going to be deploying. So to just get that, that's just another smoke test there. And then lastly, we can see the pods that are running the Fuzzball operator. And as you can see, we have 3 instantiations of this that are all currently running.
Yeah, and I was actually corrected on that. The 3 out of 3 is not, this isn't like 3 replicas of it. There are 3 containers that make up the operator controller manager that are all involved in this process. So it's not quite 3 instances, but we do see that the 3 containers that are expected are running.
Gotcha. Thank you, Jonathan. All right, so now that we have the operator installed, we can begin installing the Fuzzball Orchestrate platform. So to do that, I'm first going to set another few environment variables to configure Fuzzball Orchestrate. So IP1 here, I believe, is the IP of the load balancer that is used by Kubernetes. In this case, since we're deploying on-prem, the cluster uses Metal LB. The NFS server, an NFS server is defined, and this NFS server is basically used to store the substrate configuration so that the substrate node can basically pull the substrate node mounts this NFS server as well and can basically pull the configuration from there so it knows what orchestrate cluster to actually talk to. And the realm ID is basically a UUID of a key cloak realm, I believe, which is used for authentication and used to kind of organize sets of users within this Fuzzball Orchestrate deployment. Jonathan, did I get most of that right?
Yeah, that's all fine. The realm ID here is a universal unique ID, a UUID that this deployment, as I know how we're going to do it, but is going to generate a realm in a key cloak that will be stood up on our behalf using this UUID. Alternatively, if you have an existing key cloak, it can be configured differently to access an existing key cloak realm. And so then you would plug that value here. And a cat is also necessary. Oh, you don't see this. I'm sorry. I'm looking at myself on camera, but a cat just jumped up into the frame. But yeah, so all great. This is going to do a totally normal deployment. Oh, maybe one thing I'll say is that this IP address is the one that we want to use to export the Fuzzball external services. This is the IP1. So as a prerequisite to this, we expect the local Kubernetes environment to have a Metal LB load balancer deployed with a pool of addresses. And to make it repeatable, we're saying which address from that pool we want to use. And we happen to know, because we defined the pool, that 10.0.0.99 is one such available address.
Cool. Thank you, Jonathan. So now that I have these variables set, I'm basically going to create a configuration for the Fuzzball Orchestrate platform, which is in this YAML definition that I'm going to paste. So, and this is basically going to take some of the variables I've set up here and kind of throw them into this configuration file called fuzzball.yaml. So as you can see, just pasted that into there. So, and this basically just takes some of the various variables I've set in the environment and sets them in this Fuzzball config. So now that I have a configuration, I am ready to start deploying the Fuzzball Orchestrate platform. And to do that, I'm going to run kubectl apply and and pass this fuzzball YAML file in. And as you can see, I have a deployment started, and to kind of watch the various, to watch it deploy, you can basically run this command here, which is outlined in our documentation, to kind of just watch the logs of this entire platform kind of getting stood up. So, yeah. While we wait for that, I can switch over to our compute node, and we can kind of get that installed. To install Fuzzball substrate, I'll just make this big, quick. Cool. Before we do that, Jonathan, is there anything else you'd like to add?
The one thing that I think might be cool is to demonstrate like that object that we just applied into the cluster, it's resident in the cluster. So you could like get it, you can see its definition. And the coolest thing to me is that you can just edit it in place. And we shouldn't change anything about it during the deployment, but you can run like kubectl, edit, fuzzball, I think fuzzball orchestrate is what we called it. And just edit it in place, and then the next time the operator wakes up, it sees that that has happened and makes the change in the cluster, which is a good experience in my experience.
Gotcha. So, and just to show some of that, we can just do something like get pods.
So it's not pods; it's literally a fuzzball. No, not pods.
Oh, yeah.
So you're getting the fuzzball called Fuzzball orchestrate.
Fuzzball orchestrate. Yes.
So you need an additional fuzzball between get and because
gotcha.
you're getting an object of type fuzzball named Fuzzball orchestrate.
Capital F fuzzball.
I think it doesn't matter. What you have there should be fine. Yeah. So there we have one, and instead of get, you can say edit. Which just puts the YAML definition up in an editor, and you can just change it here. So like if you scroll down a bit, you can see you've got some metadata up here that makes it harder to see, but there's the metadata that we had specified in that fuzzball.yaml. So you can either keep that fuzzball.yaml and put it in Git or something like that, and then if you want to make changes, reapply it to your cluster the same way. That's one thing you can do. Or if you just want to manage it statefully, you can just make changes right here, and they update the configuration of the cluster. And that's the real value of the operator, is that it's really dynamic and it's responsive to the configuration that you apply here.
Gotcha. Thank you, Jonathan. All right. So now that this is deploying, we can just go over to our compute node real quick and get that stood up and go through the install process of that. So to do that, first I'm just going to configure some firewall settings just to, and this will basically ensure that. So this will basically put the internal interface in the right firewall zone and make sure that our nodes are communicating correctly with each other. Next, I will start by installing CIQ Mountain and enrolling it and enrolling this node into Mountain, and then installing Fuzzball substrate onto it. So to do that, I'm just going to paste these commands real quick. So just installing the Mountain tool right here, and then enrolling my server using the access key. And then from there, I'm going to enable the Fuzzball product, Fuzzball orchestrate. And then afterwards, it's a simple DNF install to install Fuzzball substrate.
And while this is going, maybe one little nuance here, because that Fuzzball substrate orchestrate might seem odd to people. So there is a separate Fuzzball substrate package that just installs Fuzzball substrate. You can see it here in the dependency list. Fuzzball substrate orchestrate is the plugin that allows Fuzzball Substrate to connect to and receive jobs from Fuzzball Orchestrate. So installing that installs the whole stack.
Gotcha. And this is basically just one way of getting Substrate running on a node. If you're running, like, let's say a werewolf cluster, you could probably create like something like a Substrate node image, which you could deploy to your compute node, so you wouldn't have to do it by hand like this.
You say you could. We have, of course, and we intend to provide that as a thing that if you're using both Werewolf and Fuzzball, you should be able to get from us, or at least a base image, a starting point that we could help you configure them.
You beat me to it. I was going to say, I feel like somebody on this webinar has done that before.
Maybe a few times.
Cool. So after Substrate is installed, I'm just going to set some environment variables for that service right here. Ooh. Let me just paste this. Ooh. Just going to do this, and then this will basically tell Fuzzball Substrate where to get its config from, and this is basically the NFS server, which Orchestrate is publishing the configuration to for Substrate to pick up. So once I have that set, I can just go ahead and CTL start Fuzzball Substrate like so. And then just hit it with a quick status, and we can see that this is running. So it takes a little bit for the Orchestrate platform to fully get deployed and up and running. So we're going to change gears a little bit. I'm going to switch my screen share over to a deployed environment, and we can show you what that kind of looks like once it's done deploying. So let me switch over to this guy here. Cool. So I am on a controller node that has Fuzzball Orchestrate fully deployed on this node. And to show you kind of what that looks like on the tail end of the logs, you should see something like this at the end of your logs when it's fully deployed. And to show you that, we have all of we don't have any pods that are in an error state or in some weird state, and they're all running or succeeded. We can just run that command as just a smoke test. And from there, we can run this command here, which calls the Fuzzball admin pod and calls Fuzzball admin. And it basically checks the compute resources which are connected to this Fuzzball Orchestrate deployment. And as you can see here, I have this compute node that is talking to my Orchestrate deployment. So this node has the Fuzzball CLI installed on it. The Fuzzball CLI is also installed through Mountain. And once you have your Orchestrate deployment up and running, you can basically create a Fuzzball context. And I can show you here that I have one already created. So once your Fuzzball context is created, you can log into it. So you can do that by running Fuzzball context login direct. And I'm just going to pass in. So just throw in my credentials there. And as you can see, I'm logged in as this admin account, and I can start submitting jobs. So as you can see here, I have 2 fuzz files basically created. And let's first take a look at this hello world fuzz file. As you can see with this hello world fuzz file, it's a workflow of a single job named hello this job uses an Alpine container and as its, I guess, software environment. And within this environment, we are basically calling a shell and echoing hello world in the shell. And the resource requirements for this particular job is a single core and 1 gig of memory. So now that we've seen this workflow, let's go ahead and submit it. So to do that, I'm just going to call fuzzball workflow start hello world.fuzz, and I should get a UUID, which is returned. And from there, using this UUID, I could check the status of this particular workflow using fuzzball workflow describe and passing in this UUID. And as you can see, this workflow has finished since it's just printing hello world. You can see the status of the various stages, like the image pull and the job actually running when it started, when it finished. Additionally, using the CLI, you could also gather logs from this particular workflow by pointing it to a specific job which you want to check the logs of. To do that, we can just do fuzzball workflow log, pass in the UUID, and specify the job name which you'd like to look at. And from there, we can see the log. This particular job has printed hello world, which we saw in the fuzz file before. To do something slightly more interesting, we can take a look at this printer fuzz file that I have also on here. This workflow is a single job as well, uses the job's name printer. The image that it's using is also an Alpine container. And basically what this job does is it prints integers 1 to 300 with a 1 second sleep in between. So, and resource requirements for this, also 1 core, 1 gig. And one additional thing that we have in this particular workflow is a policy, which you can see here. And this is basically setting a wall time for this particular job of 10 minutes. So I'm just going to go ahead and submit that. So fuzzball workflow start. And I'm just going to pass in printer.fuzz. Boom. Okay. So as we can see, we have a UUID, which fuzzball returned to us. From here, we can do something like workflow log, pass in the UUID, and pass in the job. And as you can see, it's basically printing these integers. The last thing I'd like to show on this demo is, give me 1 second. Let me just go ahead and refresh this. Cool. So let me switch my screen share and switch to.
We do have one question while you're doing that, Jonathan. You may want to take a stab at it.
Yeah, so the question on LinkedIn was, can the config be sourced from anywhere else other than NFS, with an example of like an S3 endpoint or other type of share. So the use of NFS here is optional. You could get the configuration, like it's just generating a config file, actually a couple config files. That could be placed anywhere, but there's not currently any support for publishing the config from Orchestrate directly to an S3 endpoint. Or pulling it directly from an S3 endpoint to Substrate. You'd have to manage that separately. You could take the config that Orchestrate is publishing, that it's generating, and yourself publish it to S3, and then as part of your compute node pull that down to a local file and read that in from with Substrate when it comes up. So that could be done, and I think that would be relatively straightforward if it were if a requirement like that came to us. The biggest issue would just be handling the credentialing for it, I would think. But it'd probably be possible to do something like there are secrets in it, so you would want a credential for reading it as well. But yeah, plausible, possible to do right now with some integration work, but also doesn't seem, as I sit here, like it would be a huge ask if it were necessary to be more integrated into the product.
Cool. So I guess as you can see here, I have pulled up the Fuzzball web UI, which is I guess connected to the Fuzzball orchestrate deployment, which I was submitting jobs to. As you can see here, my printer.fuzz file, which I submitted previously, is currently running. And if I wanted to look into this particular workflow, I could click into that. And if I wanted to view logs from the printer job, I could just simply click on the printer job, click on logs. And as you can see here, we can kind of see that it's printing an integer and increasing after every second.
You should click on that terminal tab too.
Oh, yes. And I can also get a shell on this particular job inside the container. So I can do something like M. You can see I'm inside a Fuzzball job. I could run commands in this. Hello. You can touch test.
Maybe just do like a PS in there too, so we can see that the job is running in it. Yeah.
Yep. So, yeah. So running a PS, we can see that my job command from the fuzz file is currently running in this container. Yeah. Cool. Well, that is all I had prepared for today's demo. If there's anything the audience would like to see, yeah, feel free to drop that in the comments. Your use cases, all that type of stuff. We are definitely interested in what our audience would like to run using Fuzzball.
Trying to see if we have any more questions. Thank you for that, Brian. That's fantastic. Yeah, Jonathan left, and he's back.
He's back.
No, I appreciate the demo. It's been good to see it, and I'm glad to see all the changes that are going on. It's been interesting having people come in and ask, like, how does this actually, what is this part of Kubernetes? Like, how do they play together? What does it mean? So thank you for explaining that, Jonathan. You and Brian, that's very helpful.
Yeah, one thing that might be, like, we've said this on the webinar before, but just to be clear, for people who might not be familiar with Fuzzball and the different container platforms that we're dealing with here, the big thing to take away from that from an HPC standpoint, from a performance computing standpoint or a performance sensitive standpoint, is that we use Kubernetes and the kind of traditional OCI ecosystem as our application platform, but it's not where the performance sensitive part of your workflow runs. The performance sensitive part is still containerized, but it's containerized with technology that is more akin to Singularity or Aptainer, that's designed for execution in an HPC environment and doesn't have some of the same performance characteristics of traditional OCI, where OCI is really built for resiliency and reliability for services, web services especially. Aptainer and now Fuzzball Substrate are designed around providing a container experience, but for an HPC use case, not having as many layers between various parts of the networking stack, for example, is a big part of it.
Thank you, Jonathan. Well, if we don't have any more questions, I really appreciate you guys jumping on and doing this, and look forward to see more as these workflows come out. And I know there are other things that you guys are working on with other software vendors and being able to run those. I don't know if you want to hit on those real quick.
We've got some exciting stuff coming up with like running larger things that have been difficult to containerize in the past. I don't want to like make too many promises for how quickly we'll be able to show them. We've done them in the past, but we've made some changes, or we've done them internally, but we've made some changes to how user IDs get mapped into containers that need a little bit more baking time for how that affects storage and accessing storage from within the container. So watch this space. Hopefully in the next few weeks we'll be able to show something more publicly on running some larger ISV type applications that do a little bit more than say hello world to your screen. Not that you can't do more things now, but they're just not any more flashy than that a lot of the time.
Sure. Great.
Yes. Flashy ISV.
Brian, do you have any closing thoughts?
To come. Yes.
Yes.
You've been doing all the demo work. You're just been sitting here being quiet, enjoying what I'm watching. So, anything to close out with?
I guess other things that we're kind of working on right now, things like running services within Fuzzball. So in particular, like one use case that comes to mind is you're training some AI model. You want to deploy this model as a service and then run inference against this service to, I guess, validate your particular model. So that is coming down the pipe, and then also possibly running Fuzzball on the cloud as well with you on various cloud providers. So look out for that. Yeah.
Very good. Well, thank you guys. Thank you for joining today. Thank you everybody for watching. We appreciate it. And again, stay tuned, subscribe, like. Love to have you guys come back and see what else these guys have been up to and what they're working on. So really appreciate you. We'll see you again next week.
Awesome. Thanks.
See you later.
Bye.